ఎంత మీ ఈజీ చలానా
ये पेन ड्राइव थी ना फिर इसमें
चलो ले आएंगे
अभी जो पोस्टर लगा हुआ
उससे लगा
पढ़ा कैसे हो His नाम से सेव सब part of सब लेके आना था मैं घर से सामान चले नहीं
Ingenuity and Innovation. Today's event is being organized by the Chandigarh chapter of National Academy of Sciences India in association with Department of Chemistry, Punjab University, INSA, Indian National Science Academy, INYAS, that is Indian National Young Academy of Science, and CRIKC, Chandigarh Region Innovation and Knowledge Cluster, and Society for Promotion of Science and Technology in India, SPSTI. We are indeed grateful that we have with us Director IISER Mohali, Professor Anil Tripathi, guest of honor and former Executive Director Navi Mohali, Professor Rakesh Suri, Vice President SPSTI, Professor Arun Kumar Gover, President SPSTI and retired IS Dharamveer Sir, General Secretary SPSTI and retired Professor Kia Dharamveer, Vice Chancellor of MIT University, Professor R.K. Kohli, and Chairperson, Department of Chemistry, Professor Gangaram Chaudhary, Seminar Coordinator, Dr. Subhash Chandra Sahu, all the faculty members, various other dignitaries, research scholars, and students. I once again welcome you all. May I now request each one of you to please rise up for the Punjab University anthem. May I now request Professor Gangaram Chaudhary, Chairperson, Department of Chemistry, to present bouquet as a small token of our warm welcome and appreciation to Professor S.K. Tripathi. Professor Rakesh Suri, Professor Arun Kumar Grover, Professor K.N. Pathak, Dharamveer Sir, Professor Kia Dharamveer, Professor R.K. Kohli. Sorry. Thank you, everyone. This bouquet is a small gesture of our appreciation for you all joining us. We are truly delighted to have you all. Now, may I please invite Chairperson Department of Chemistry, Professor Gangaram Chaudhary, for the welcome address.
Dignitaries on the dais, off the dais, faculty members from Punjab University and various institutions of under CRIKC, research scholars, students, ladies and gentlemen. A very good morning to all of you. On behalf of Department of Chemistry and Chandigarh chapter of NASI, it gives me extreme pleasure to welcome you all to this very special event for commemoration of forthcoming 79th Independence Day. We are delighted to have with us Professor Anil Kumar Tripathi, Director IISER, speaker for this very special occasion, and who will be deliberating on a journey of human civilization through inquiry and innovation. So we are extremely happy to have you here, sir. And on behalf of department, we wholeheartedly welcome you to this department. And I'm sure that your wisdom will be really beneficial for all the students of Punjab University. We are also delighted to have with us Professor Rakesh Tuli, who is part of, I always treat sir as a part of Punjab University, former executive director of Navi, to be as guest of honor for this very special event. So thank you very much, sir, for sparing your valuable time. And we extend our hearty welcome to Professor Arun Kumar Grover, who is always source of inspiration for Punjab University for organizing such events, which not only benefits to the students but society at large. Thank you very much, sir, for guiding us, motivating us to organize such event in a successful manner. So, and I also welcome Professor K.N. Pathak. Let me share with my student. So I was appointed as lecturer in this university during tenure of Professor K.N. Pathak. So at that time, he was vice chancellor. And all of you must get inspired that at this age, sir is working so much. He is frequently visiting to Department of Physics as a emeritus professor and actively engaged in promotion of science and technology in India. So we heartily welcome you, sir. I welcome all the dignitaries who are off the dais, Mr. Dharmveer, Mrs. Professor Kia Dharmveer, and other colleagues for joining this special event. Uh, this Society for Promotion of Science and Technology, we know, is very, very active under chapter of Chandigarh chapter of NASI. So such programs are being very frequently organized, and science and technology is being promoted for the society, for the benefit of society. So I believe that such program will continue and will keep motivating and guiding our student. And I'm sure that today's deliberation by Professor Tripathi will really motivate our student, because uh, it is because of inquiry and innovation. So I could get highlight of his lecture, that how innovation can be helpful for the society. So I would like to appraise that Department of Chemistry is one of the prestigious department of this university, and for last 5 years various faculty members, they have got grant of around 25 crore rupees, and are publishing in, and that also include around 2 crore grants from industry. So in our department, we have very good central instrumentation laboratory, along with a pre-incubation facility, wherein department also tends to nurture good number of startups. And I believe the motivation which will be given by our honorable speaker will really motivate our students to be entrepreneur, to be startup, so that they can get very good employability at the end. So thank you so much, and I believe that all of us will be benefited through such event. Thank you so much.
Thank you, sir. Now, to brief us all about the lecture series and to deliver the opening remarks, may I now invite President SPSTI, Professor Arun Kumar Global.
So good morning, all. My own teacher, Professor K.N. Pathak, our speaker for today, Professor Tripathi, fellows of the Science Academies, including NASI, INSA, and Bangalore Academy, members of INYAS, faculty members of FUSE, students, ladies and gentlemen. As a background, let me just recall for you that in 2019, the then president of the Chandigarh chapter of NASI, late Professor IBS Pasi, had an MOU with SPSTI that the two of them will organize public events of interest to the society together. So Professor Pasi wrote me in as the chair of a small subcommittee which will plan these lectures in partnership with INYAS and the CRIKC institutions. So very soon the pandemic arrived. So during the pandemic period, we had our 73rd Independence Day. So next year, it was announced that India will commemorate the 75th year of independence by organizing events lasting over 75-week period, commencing from March of 2021. So the president SPSTI asked me, what can we do? So we said, though the political leaders fought for the independence of India, the agenda for development of India was conceived by the teachers, scientists of India before the independence. So whatever has happened in India, it is the implementation by the teachers, scientists of India, whatever they had planned for independent India. So let's use this occasion of inviting icons from all across India by telling us about the newer institutions which have got created in independent India and newer nurture initiatives which have been launched in independent India. So we organized these 19 lectures, and the last lecture was delivered few days before the 75th Independence Day by the then President of INSA, Professor Ashutosh Sharma. So the next year, the commemorations continued and we organized lectures by the directors of the CRIKC institutions telling us about what they plan for their respective institutions in run up to India at 2047. So we had a series of lectures, and in the just before the Independence Day of 2023, we had a last lecture by Professor Renovich. So this process is continuing. So every year on the Teachers' Day, we commence the series of lectures which are planned together by the science academies, INYAS, SPSTI, and the CRIKC institutions. So this year we thought that we will do this a little before the Teachers' Day. We should start the series of lectures as soon as the institutions open. So most institutions are open. Older students, actually, the classes also start by 1st of August. So we decided to have commemoration of Independence Day as a part of our activities. So it is in that series we thought we'll request Professor Tripathi, who is Vice President of INSA, who is also on the executive body of the Bangalore Academy, and he is head of one of the CRIKC institutions. So we thought we will request him to deliver this first lecture of this academic year. So we are very happy that he consented. All of you are present in large numbers. This lecture is in the hybrid mode. Recording of this lecture will be available later. So though the lecture may have an audience of 100, maybe an audience of only 50 in the hybrid mode, but we expect this lecture to be listened to by hundreds of people thereafter, okay, as the lecture would become, as the link for this lecture would become viral. So it's a public lecture in that sense, available since it would be on the YouTube, so it's globally available. So thank you, Professor Prof. I must thank all of you who have spared time to come here, in particular to Professor Pathak, who has graced the occasion today and honored all of us. Thank you, Professor Pathak.
Thank you, sir. Now, may I please invite Professor S.K. Mehta to introduce the guest of honor.
Good morning to all of you. And we have our chief guest, Professor Anil Kumar Tripathi, Director, IISER Mohali. We have with us Professor Arun Kumar Grover, Vice President, SPSTI, and former Vice Chancellor, Punjab University. Guest of honor, Professor Rakesh Tuli, former Director, NABI. Professor K.N. Pathak, former Vice Chancellor, Punjab University. Mr. Dharamveer and Professor K.R. Dharamveer, who is President and General Secretary of the SPSTI, and Chairman of Chemistry Department, Dr. Gangaram Chaudhary, my colleagues, and all the dear students. I have been given the pleasant duty to introduce Dr. Rakesh Tuli. Rakesh Tuli is an internationally acclaimed eminent academician, science administrator, and researcher in biotechnology. He has been senior research advisor, University Institute of Engineering and Technology, Punjab University, Chandigarh, during 2014 to 2022. He held several key positions. There are so many positions he has held, but I will like to tell you that he was director, National Botanical Research Institute, Lucknow, from 2006 to 10. Executive Director, NABI, that is National Agri-Food Biotechnology Institute, Mohali, from 2010 to 13. And starting with INSA Young Scientist Medal in 1983, he had so many honors and awards, and particularly CSR Technology Award in 2005, J.C. Bose National Fellow Award 2007 to 2021. And then from the university side, he was given Professor P.N. Mehra Award in 2009. And recently, he was conferred the 10th Professor S.R. Kashyap Oration Award in the Department of Botany in 2024. Dr. Tully is a fellow of all the academics, Indian National Academy, Indian National Science Academy, National Academy of Sciences, Indian Academy of Sciences, and he's also honorary fellow, International Research Society for Complementary and Alternative Medicine, Toronto, Canada. His research includes plant biotechnology, genomics, food and nutritional biotechnology, crop and bacterial genomics, and biochemistry. So I heartily welcome Professor Tully, Dr. Tully, for this very important lecture. Thank you.
Thank you, Professor Mehta, for your very kind words, both as a friend and as a contemporary academician with me. It's a very heartening that a number of gem organizations in our region, in the Tri-City area, especially in the Punjab University, CRIKC, SPSTI, jointly with the local chapters of INSA and NASI, have been periodically organizing lectures by some of the most eminent scientists and academicians in the country. As also mentioned by Professor Grover, a number of these lectures have been encouraging, I would say, not only youngsters and imparting them with deeper vision and knowledge, but also they have been very helpful to CRIKC institutes to write joint projects and to carry on the science and education map forward. However, this lecture, for a number of reasons, is a very special lecture. It is special not only because the talk is to be given by an administrative head of a highly distinguished institute in the region, but I personally feel it's also important because Professor Anil Kumar Tripathi has done deep research in an area which is very important to agriculture in this country and particularly uh, in this region. And this area is broadly, biologists know that, chemists also, I guess, know that, is called as biological nitrogen fixation. As you know, crops require nitrogen for growth, and about 60% of farming actually depends upon fertilizers, especially nitrogen fertilizer, which is chemically synthesized by the well-known process, Haber-Bosch process. See, this process, chemists know more than anybody else, uses a very high level of energy, fossil fuels, and actually it is estimated to contribute to 1 to 2% of the carbon dioxide emission globally. Therefore, the process is environmentally unfriendly, though very important. Besides that, application of nitrogen fertilizers in the fields lead to oxidation of chemical nitrogen and therefore formation of things like nitrous oxide, which are even more uh, difficult to handle, and they are also classified as serious greenhouse gases. Following the application, there are additional problems like leaching of nitrogen through the soil, which lead to health hazards, and to uh, disturbing and the soil acidity and thus affecting crop growths. This region in northwest India actually very distinctly faces some of these problems. I say all this because Dr. Tripathi has made important contributions to developing alternative ways to providing nitrogen to crop plants. He has made significant contributions in identifying and improving bacteria that associate specifically with non-legume crops. They associate with the roots and also with the surface phyllosphere of the plant and fix atmospheric nitrogen and therefore provide a supplement besides whatever chemical nitrogen is given. He has made contributions in improving the efficiency and capabilities of such bacteria through genetic and genomic approaches. See, this area of research is truly futuristic in terms of the three I's that are highlighted in the title of talk of Professor Tripathi, Inquiry, Ingenuity, and Innovation. I personally feel his presence now in Chandigarh region opens the prospects of IISER steering the institutes in neighborhoods, especially Punjab University, National Agri-Food Biotechnology Institute, Punjab Agricultural University in particular, Haryana Agricultural University in particular, for research in reducing the need for nitrogen fertilizers, specifically in wheat and rice. The nitrogen, this region therefore can take up very challenging areas like can we, for instance, reduce the need for nitrogen fertilizer in wheat and rice by say 20%, 20% of the current recommendations in the next 5 to 10 years. There are more complex areas in the area of biological nitrogen fixation, which could be targets for the region. For example, introducing functional nitrogen fixation genes into cereals, designing cereals, wheat and rice particularly, to form nodules like they are formed in nitrogen fixing legumes, engineering of nitrogenous system and bacteria that will provide nitrogen to crops even at high temperatures and salinity. See, all these are problems. High temperature, salinity are problems in this region, and excessive application of nitrogen fertilizer, etc., are also serious problems in the region. Therefore, successes in these areas can bring dream breakthroughs to the region and also evolve global leadership in India in addressing critical needs of agriculture and environment. So the second reason why I feel this talk by Dr. Anil is very special is hidden again in the title of the talk. The journey of human civilization through inquiry, ingenuity, and innovation. The depth and width of this talk actually is unfathomable. The three I's in the title are multiplicative. They are not merely additive. Therefore, I would call this as I cube, not three I's. Lower development of contribution of any of these three actually leads to a greater influence on making the contributions much lesser. I would also add a G to this, a culture of growth for sustained economic, strategic, and cultural influence by the civilization that emerges out of these three I's working together. Therefore, I suggest that we call it as I cube G, which leads to developing a vision for a transformative culture for making ourselves a globally leader uh, in the country. See, as we know, till the early 18th century, India held between 25 to 33% of world's GDP, making it one of the largest economic powers globally. Rise of India's innovation capacity and thus civilizational power till the early 18th century needs to be now compared with the ongoing era of what I may call as missed opportunities. From the mid 18th century till late 20th century, a decline of I3 culture has happened, and the GDP fell down to as low as 1% of global GDP. Following the opening up of economy in 1991 and subsequent investments in efforts and infrastructure in introducing new technologies and methods of knowledge dissemination, the GDP has now increased to around 3 to 4% of global GDP. This transformation is welcome, though rather slow. Hopefully, new education policy, which has been implemented during the last 5 years, will turn out to be another important step towards ushering India into the I3 culture, into the true I3G culture. Talks like this on national occasions like Independence Day are reminders to transforming the system. Thus, this talk is a special feast given to us by the Tri-City organizations. Thanks to Dr. Tripathi for choosing this very important title. Thank you very much.
Thank you, sir, for your insightful words. Now, may I request Professor Lavneet Kaur to introduce the speaker?
A very good morning to Professor Tripathi, the Director IISER Mohali, Professor Arun Grover, the Vice President SPSTI and the former Vice Chancellor Punjab University, Professor Tulli, and the former Director NABI, and Professor K.N. Pathak, the former Vice Chancellor of Punjab University, Mr. Dharamveer, Professor K. Dharamveer, Mr. Chaudhary, the senior professors offline and online, the research scholars and the students. I'm delighted today to introduce the speaker of the day and Professor Anil Kumar Tripathi, who is the director of IISER Mohali. He obtained his MSc and PhD degrees in botany from the Banaras Hindu University, and later he joined the same university in the Department of Biotechnology and carried out the teaching and research in the area for more than 25 years. Prior to joining the IISER Mohali, he was a senior professor of biotechnology and director of the Institute of Science at the Banaras Hindu University. He served the Banaras Hindu University in various capacities as a coordinator, School of Biotechnology, coordinator, Center for Bioinformatics, and the coordinator, BioNest, BHU. He was also the director of the Central Institute of Medicinal and Aromatic Plants at Lucknow. And there he worked for the cause of the rural empowerment through the cultivation and the processing of the medicinal and the aromatic plants. And in this process, he has established the first phase of the CSIR Aroma mission as its first mission director. And not only this, under his leadership, he has contributed in many ways to CSIR CMAP. And for this, it was recognized with the CSIR Technology Award in Life Sciences in the year 2015 and the CSIR Award for the S&T Innovation for the Rural Development. He has many accolades to his credit, and his research interests include the genetics, the functional genomics, and the system biology of the plant growth, promoting rhizobacterium for the synthetic biology applications. His research work has been published in more than 90 full-length research papers in the peer-reviewed journals, and he has also supervised 22 PhD students in the area of biotechnology. And he has worked with various sponsored projects, not only from the national level, but at the international agencies also. He has been a fellow of all the three Academy of Sciences, the prestigious Academy of Sciences of India and the National Academy of Agricultural Sciences at New Delhi. As I said, that he has been awarded by various bodies like J.C. Bose National Fellowship in the year 2020. And he has also been a recipient of several awards, including the UGC BSR Mid-Career Award and Professor B.D. Tilak Lecture Award. And not only this, he has also been the part of the various governing bodies at the national level, like NIPGR New Delhi, NIPER Raebareli, DPT Task Force on the Environmental Biotechnology. And so I welcome you, sir, in, I would say, a very integrated talk to be delivered by you today. And the audience is also very much enthusiastic to hear me say. Right.
There is some goof up with my presentation. I brought a PPT, which is not having it, so I got it transmitted through email. And now I'll just take a couple of minutes to open it on my email. So to that time you have a breather, you know. Very good.
And we have also the vice director. Yes, sir. Yeah, it's it's more advanced than applications.
So anyway, the file is already in hand and it's getting downloaded. In between, I should express my sense of pleasure of being here and also acknowledgement to some of the leaders of science in the country, Professor Grover, Professor Tuli, Professor Pathak, Professor Mehta, Professor Tiwari, many others who are present here. I've been looking for an opportunity to be at Punjab University, particularly the chemistry department has a very high place of reverence in my mind, especially because of its association with Dr. Shanti Swarup Bhattacharya. Because Dr. Shanti Swarup Bhattacharya wrote the Kulgeet of Banaras University. And all over the world, all the students and alumni who assembled together, they jointly sing this song written by Dr. Bhattacharya, and they have goosebumps. And in BHU, about a few years back, I started a series, Dr. Bhattacharya Memorial Lecture Series, on his birthday. And on the first lecture, we wanted to screen something about Dr. Bhattacharya. And
slideshow. जहाँ पे शेयर किया है विंडो भी है ना entire thing.
हाँ मैं वही तो कह रहा हूँ
entire screen. शेयर करना entire screen. ये विंडो नहीं है हाँ शेयर वो थोड़ा सा पीपीटी छोड़ मेरे पास तो मेरा ठीक है स्पेशल कुछ नहीं है so what is about it
so I was mentioning that we wanted to screen a small film on Dr. Shanti Swarup Bhattacharya. I approached CSIR because Dr. Bhattacharya was the creator of CSIR system, and I couldn't get any. And then Professor Rajkumar was here, Vice Chancellor. I approached him, and then he connected me to the right person. I could get a small film, which I screened at Banaras University. So, Punjab University Chemistry Department has such a strong connection with Dr. Shanti Swarup Bhattacharya, and that is also a connect with Banaras University because a common person, Dr. Bhattacharya, whom we all respect from the core of our heart. Well, today's talk, I had a choice whether I can give on the scientific topic on which I work or some thoughts which I have about science. So I thought when I'm giving a talk in chemistry department, I should probably talk about some general issues, general thoughts which I have about science, how it was done in the past, and what is it that we need to do. At least we should be aware when we do our research today or tomorrow. So with that, I had conceived some thoughts in which I have tried to put in here, summarize here. The journey of human civilization through inquiry, ingenuity, and innovation. Now, if you look at we have a pointer. So, if we look at the animal versus human, you can see that the human brain is larger and more complex than the brain of animals. And one very important feature of human being is the advanced reasoning, abstract thinking, and problem solving, which animals have to very limited extent. And the human brain is highly developed and is able to enable complex functions. It is enabled for complex functions, which animal brain is not. And you can see the size of human brain vis-a-vis the size of chimpanzee and rhesus monkey is very small. So we are gifted with unique capability of thinking, innovating, and trying to connect the dots. Now, if you look at the example of human creativity, or I would say here, the animal creativity, the examples of animal creativity which we see is in the creation of nests and the combs of nests by weaver bird, honeybee, and then the mounds by termites and the leaf cutter ants. So these are some of the examples of their ability to create something. But if you think about, I was thinking about the examples, that what are other examples of creativity? We don't find much. So it is the human being which is actually gifted to not only think, but also to create. And it has been blessed with variety of kind of enabling features in the body that one can create the things. Now, a few clarifications about the human creativity. The first thing is the sense of inquiry. We are very curious. Animals are also curious, but they have a very limited ability to address their curiosity. So, asking questions and seeking knowledge. The ingenuity is to use that knowledge, use those answers to create, and being resourceful, resourceful thinking to develop new products and processes. So once you have asked a question, you got the knowledge, then you think, then can we apply this knowledge? And that is called the ingenuity. And innovation is that if you have developed some concept, then to keep on improving that is the process of innovation. And there are myriads of innovations, millions and trillions of innovations which are responsible for the present day civilized life of ours. And this continues. Every little change which is having a utility value is an innovation. And you will see that the important milestones of human civilization, if you look at, the first thing was our ability to create and control fire. Fire was there. Humans used to observe fire, but we did not know how to create fire and how to control fire. Now, this ability has brought the transformation. And if you look at the several other milestones of human civilization, you see the writing, the knowledge, the language was created, and this language resulted into creation of alphabet and our ability to write down and store the knowledge, because human brain has a limited capacity. Although in ancient times, Shruti used to be the most frequent way of transmitting knowledge. But Shruti also had its own limitation. And there's also possibility of distortions in one generation to another level of information transfer. So it is better to have a system, and that could evolve because of the writing ability. The wheel. See, the mobility was a big problem, and I will dwell upon this for some time, that the discovery of wheel, or it is the phrase is called inventing the wheel or reinventing the wheel. That phrase is very common, and I will come to that also. Then coming to the Bronze Age and Iron Age, our ability to make the implements for survival and better living. And then Silk Road, Renaissance, scientific revolution, industrial revolution, discovery of electricity, aviation, computers, and then exploration of space, followed by internet, and today the age of artificial intelligence. So these all developments have taken place through a series of inquiry, ingenuity, innovations, and present day technology development. Now, this all started by asking questions, exploring the cause and effect relationships. And this is from observation of nature to deployable products and technologies. The classical example is that of C.V. Raman and of the Newton. The basic question, why sky is blue? If you delve deeper into this answer, then the Raman spectroscopy was born. And then based on the Raman spectroscopy, Now there are hundreds of equipments which are required for variety of kind of analytical applications all over the world. Raman spectrometry is extremely useful. So you can see that asking a very fundamental question, that why sky is blue, and going deeper into it has resulted into the instrumentation or the methods which are now answering variety of very useful applications, be it forensics, be it investigation, all kind of things apply the Raman spectroscopy. Now, if you look at the leading scientists who changed the world, you can see the Albert Einstein, Isaac Newton, Marie Curie, Galileo, Charles Darwin, Stephen Hawking, a long list of scientists who have made their substantial contributions and have been able to change the world and change the way we think about life and the nature. So, large number of these people, and I think every student of science is familiar with the contribution of each one of them. Now, similarly, if we, we draw our attention from the individuals, if you look at the inventions which have changed our world, you can see that there are a variety of these inventions. You see the submarine, calculator, piano, stethoscope, bicycle, all these developments have impacted our life. They have enriched human civilization, made our life more comfortable and more secure and safe. Now, the difference between an invention and innovation, most of you should be familiar, but there is some amusing facts about it. The invention is about creation or discovery of a new product, process, or idea. Innovation is transformation of an existing idea, product, or process into something new, something better. And invention occurs when a new idea strikes, and innovation occurs when there is a need of improvement. And invention is having high risk and uncertainty, whereas innovation mitigates risk through market research and prototyping. And the examples are in front of us, the telephone, computer, and then further modifications, improvement of the model of these telephones and computer. These are called innovations. The irony is that inventors get the credit while innovators make the money. So inventors, they are the original creator of something, but they do not get as much money as the innovators get. And that is why all over the world, there is emphasis on the word innovation, because innovation gets you money, but innovation is not possible without inventions. Now, the genesis of invention lies in the pursuit of original questions, whereas the genesis of innovation lies in improving the invention to meet user needs and make money. So this is the irony. Although invention is fundamental, but doesn't get as much money as innovation gets. Now, coming to the evolution of human being, about 200,000 years ago, the Homo sapiens, they appeared. After a long, long evolution from Australopithecus to Homo sapiens. And from Homo sapiens, appearance of Homo sapiens, to the modern day human, which can be exemplified in the form of Elon Musk. This human civilization, earlier human, was not considered to be civilized. It was close to animals. But during these hundreds of years or thousands of years, Homo sapiens has supposed to have become civilized. And what are the consequences of civilization? What is the process of civilization? That is what we'll pay our attention to. To begin with, this civilization, initially we were hunter and gatherer society. We did not care about next day. Every day you hunt like every animal. You see the birds in the grassland. You see the animals. They are feeding. All the time you see that they are feeding. They are not bothered about tomorrow. They are feeding for today, for their survival. And they will kill animals and survive for a few days and then look for another animal and kill it. The major advancement happened, as I mentioned earlier, is with the ability to create fire and they control fire. And this happened about 1.4 million years ago. And at that time, that was the Stone Age, when different kind of tools were built to survive, to kill and to survive. These kind of implements were created during the Stone Age. Now, Neolithic Age started with the construction of shelters and transition from nomadic life to the settled life. You can see that using the naturally available resources, they applied their mind and tried to create shelters for themselves. And this shelter provided some kind of safety to us. So there was transition from day-to-day survival struggle to a secure and safe place where they can, stay together. They can live a family life. Sorry. I'll maybe for the I'm ready. I'm now from astrological positions. You know what about the date of birth on positive, also the date of birth of Rama and Ram. The position of star at that time. That can be much more compact science, basic science. Just found out. How do you like the 10,000 Well, the standard procedure for any scientist is search of literature. So this, what I have written is based on the literature that these dates are there. I have not discovered it myself. So most often we depend on the literature. And how that literature was created was based on the studies of the archaeologists. They have different kind of methods, and the dates have been getting changed based on the instrumentation and the evidences. The dates have been changing. So these dates are not sacrosanct; they are not fixed. But these are the based on the available methods, logical methods, and the instrumentation methods. These are tentative dates which have been described. But the question which you asked about the Valmiki and Brahma, etc., I think the archaeologists would be in a better position to answer that. My perspective, which I'm going to present, is slightly different. Well, so the perspective you'll quickly see that when we started settling down, when we made our settlements, then the question came that how do we survive? And for our survival, the human being started domesticating animals and plants. And this process of domestication started. So we identified variety of animals which can be domesticated. And you can see that with the given record, we find that the animals like cows, pigs, sheep, goat, and dogs, they were domesticated about before 10,000 years ago. So they were our companions for more than 10,000 years. And there are pictures which I have, some of which I have shown about the wall paintings and about carvings, which show that this domestication of animal was there, and human society started depending on these animals for variety of our needs. And you can see that cat, horse, camel, duck, all these, their domestication gradually started. Once we found that there are animals which can be domesticated, they are useful, we started domesticating. Now you can see that there are different applications of different animals. Here you can see the cow, a camel, horse, and buffalo. They are used for a variety of purposes of agriculture. Now, when the agrarian society evolved, you can see these are again these paintings, and the agrarian society evolved by basic curiosity, observation. You observe what is there in the nature, then you see which is more useful. Then you start selecting. And when you select that, you go for domestication because the seeds are there, the knowledge was there that plant, is regenerated through seeds. So these seeds were collected, and then at one place cultivation started, and this is what is called cultivation or domestication. And after that, when cultivation was done, the principles of breeding evolved, and by breeding you can have much better varieties, much more productive varieties. So this is the process from observation to selection to domestication, and then further improvement through breeding. And I will mention about modern methods of further improvement. Now, if you all look at these pictures, you would not believe that corn, modern day corn, you see the upper panel, there was a predecessor, originator of modern day corn, the wild maize, which was called teosinte. And the teosinte had very few grains. And from there, the process of observation and selection started in finding better and better variants. And today we have this modern maize where you have a year this is full of grains, and further improvement keeps on happening. Similarly, wild rice. The wild rice, the inflorescence or the panicle had very few grains. But over the years, after selection and breeding, today we have cultivated rice, which has a lot of seeds there. So this has gradually evolved. And likewise, you see wild wheat, if you see this picture of C, wild wheat was looking like that. Very few grains were there. But later on, by selection, by domestication, by breeding, we have modern day variety of durum wheat. And similarly, we cultivated barley. What were the things which were selected? If you look at the right hand side bottom, initially these plants were prostrate type. They will not stand, they will prostrate. And when they prostrate, they have the vulnerability to degradation and feeding by animals and bacteria. And then gradually selections were made for the erect type of plants. And most of these crop plants are now erect type. And then further improvements were done so that multiple branches are there, multiple seed bearing parts are there. So that is the process of thousands of years of selection and domestication improvement. You can see the domestication of vegetable crops. You would not believe that mustard and cauliflower and cabbage, they are very close relatives of each other. But over the years, these variations have happened. And this broccoli, for example, my son was telling that broccoli and mustard are not same. I said, yes, they are not same, but they're very close relatives. They are evolved from the common stock. So you can see that these all variants of the vegetables, they are basically the process of variation. Natural variation is there, natural diversity is there. Within that, you start picking up which appears to be more promising and more useful. So many of these vegetables, they appear to be different. For a chemist, they may appear to be completely different. But for biologists, for a plant scientist, they are very, very close relatives. Now, similarly, the watermelon. And I would like to give the example of banana. I do not know whether any of you have seen a banana with seeds. And you can see that one banana on the left side doesn't have any seeds, but the one which is having a cross section is full of seeds. And coincidentally, I have seen such a banana in Lucknow. This plant was there, full of seeds. So over the years, what we have done, we don't like seeds. So we have gone for selection where seed number is less, where the seed size is small. There are a variety of these fruit crops where we have done this kind of selections. Now, with the selection, with observation, selection, cultivation, and improvement, the need was when the human population started increasing after settlement and variety of developments, there was a need to feed the human population. And this need to feed the human population was met by these two Nobel laureates. The Fritz Haber, he got Nobel Prize in 1918 for the synthesis of ammonia from its elements. And then the Karl Bosch, he got Nobel Prize in 1931 to scaling up of ammonia production. And on the one hand, I mean, they are given the credit that these chemists revolutionized fertilizer production and changed the world for the better. On the other hand, they are also accused of the human population explosion. If they had not discovered urea, if they had not discovered this process, probably the human population would not have reached to this level. Because these discoveries led to the production of the establishment of different industries of large scale production of chemical fertilizers, and the human population on the earth increased from 1.6 billion to now more than 8 billion. And every day we have problem of food, energy to take care of the growing human population. Professor Tuli has already mentioned a few very important points. What are the problems of the chemical fertilizer? Today, whole world is trying to replace chemical fertilizer with biofertilizers, because this chemical fertilizer which is produced is extremely costly, and every government is giving subsidy. Now look at the cost to the environment, that at very high temperature of 400 degrees Celsius, this urea formation takes place. High pressure, high temperature. To reach that, you have to use fossil fuel. And this fossil fuel is responsible for producing the carbon dioxide emission of greenhouse effects. So more we are using this chemical fertilizer, more this whole planet Earth is becoming vulnerable to greenhouse effect and global warming. This is what is actually happening. And there is a clarion call from the global agencies among the sustainable development goals to replace urea fertilizers with biofertilizers or some other alternatives. So this has become a menace. The discovery of so celebrated, urea synthesis or ammonia synthesis today has become a menace, and we want to replace it. This is what I want to bring to your notice. And I'll give you a few more examples that the most celebrated discoveries of yesteryears have become a menace for us today. And then we should be aware that when we have some discoveries, we should be careful and we should be cautious. Now, with the discovery of fertilizer and the varieties available to us, we started cultivating, tilling the land and cultivating. And when you cultivate a specific variety, then the problem is that you feel it is convenient for you, for a farmer, that at one place you have one crop and you can harvest and you can apply simpler methods. It is convenient for the farmer. But on the other hand, it is also convenient for the insect pest, because they can hop from one plant to another and keep on, foraging on that and destroying that crop. So what happened that the insect pest and fungal pests found it very easy to infect these crops which are located at one place. Now, earlier, when they were scattered in the wilderness, at that time, jumping of the insects from one point to another was very difficult. But now we have placed them at one place, and it has become a very easy target for the fungal pests or insect pests or the viral pests. And then the crops were getting destroyed. And then again, the human ingenuity came that what can we do to prevent the crop damage? And for that, some chemicals were discovered. So you can see that initially in 1867, the Paris green, which is a form of copper arsenite, which was discovered. And there are many more of these compounds they were discovered. They were sprayed to control these pests. And in the process, the soil was contaminated with different kind of chemicals. And the most fundamental discovery of DDT in 1939, revolutionizing discovery and most celebrated discovery by Paul Muller that came, which was followed by discoveries or development of other pesticides, which were organophosphate pesticides, insecticides, phenoxyacetic acid herbicides, and many others. They were all discovered. And it was thought that now we have taken a control. We will be able to solve the problem of agriculture. But in 1972 itself, when this DDT became such a menace, there was a global call, that DDT should be banned. So Nobel Prize award winning discovery, there was a call from global community that this should be banned, and use of such pesticides which survive in the soil, which are not, degradable, they should be abundant. And such kind of pesticides should be, produced, which can be degraded, which will not be harmful, which can be degraded, which cannot be harmful to the nature, to the fields. So the emphasis came that from the chemical pesticides shift to biopesticides, and this is the talk about the discovery of the high efficiency of DDT. And once this was discovered, it became so rampant. And particularly, many of us have seen the farmers of Punjab spraying, the illiterate farmers or the laborers spraying pesticide without realizing that they are inhaling the same and they are damaging their health. Now, in 1962, a very remarkable book came, Silent Spring by Rachel Carson. And this silent spring was a very clean water. And there is no growth of algae, no fish, nothing was there. And then people were quite happy with that kind of thing. But when the water was analyzed, it was found to be full of pesticides. And these pesticides actually reached to these springs because of the surface runoff, agricultural surface runoff. And then this water body is polluted. And this water, we all know what kind of dangers are there. They cause acute and chronic health effects associated with this pesticide use at work. Variety of all body parts are affected by this kind of pesticides. So later on, much later, we became aware that these pesticides are extremely harmful for the nature, for our society. Then the question came that what is the alternative? And the alternative lied in biopesticides. And the biopesticide, Professor Tuli should be happy because he has been working, he devoted a very major part of his lifetime working on creating the pest-resistant, insect pest-resistant plants at NBRI. So the one thing came to knowledge that there is a bacterium called Bacillus thuringiensis, and this produces a toxin. And because of this toxin produced by it, if the insect larvae, they ingest this bacterium, the toxin becomes effective, and this is able to kill the larvae. And the insect is, and there is a learning behavior. And because of the learning behavior, other larvae or other insects, they don't come and infest that crops. So that way the crops become, protected. But this is such a, laborious and very elaborate process of spraying these pesticides, culturing this bacteria and spraying. And some of the times from the choppers, these sprays were done. So this turned out to be a very costly affair. And then simpler methods were thought that is it possible that the gene responsible for the production of that toxin can be put in the plant? And then the plant becomes resistant to insect pest infestation. And this was actually done. The transgenic pest resistant crops were created by transferring this toxin producing gene of Bacillus thuringiensis in variety of kind of plants. And you can see some examples of BT cotton and BT corn and brinjal. And Dr. Tuli spent major part of his life working on the cotton. Now you can see the difference that the brinjal, which is BT, having BT, which is safe, which is given at below, and at the upper, it is vulnerable to insect attack. Now, similarly, applying these techniques, the new variety of rice was created, which was rich in vitamin A. And a large number of other genetically engineered food crops were created, which included soybean, canola, sugar beet, alfalfa, zucchini, papaya, etc. So large number of such transgenic crops were created, and they were giving much better yield. They were protected. At least you don't have to use pesticides. Otherwise, you are contaminating your field. So that was the great advantage of using these transgenic crops. But then there was a lobby against this, and many countries, they stopped the cultivation of these BT crops because of the apprehension, because of the fear that they may have some adverse impact on the human life. But many countries, progressive countries like US and some African countries, Bangladesh, they are they have permitted the growth of these transgenic crops. And today, one major issue between India and Trump is the permission of the transgenic crops, that they want to transfer the transgenic products to India so that their farmers, American farmers, can find a market here. But Indian government has resisted, and has resisted for many, many decades, that we will not accept the transgenic crops. Now, one alternative to this is, there was a call from Greenpeace organization that to make our food safe and stop GMOs. And then came another alternative, that instead of putting an alien gene into the plant, can we make some small modifications in the plant or animals by using new techniques of genome editing? And here you are not putting any outside gene, but only making some corrections here and there. And this became much more acceptable. I think in the government of India, regulatory authorities have also given permission for genome edited crops. And you can see how finely the genome edited crops can be produced. Variety of these crops have been produced over the years. And on the top, I have given you example of the tomato. You can see all these different colored tomato, they are produced of genome editing. Small changes in the gene, they have led to production of different colors of. So this is a kind of example that how precisely you can change the fruits or vegetables. You have the potato, you have mushrooms, non-browning. Usually the problem with mushrooms is that after some time they browning starts. But you have the modified mushrooms, they remain, glowing white for a long time. So these changes have taken place, and these crops are going to be accepted. Hopefully they will be accepted, and humans will have much more time, much more food and nutritious food to survive and prolong their lifespan. Now I'm coming to a different dimension. You have seen that this questions the sense of inquiry, ingenuity, and innovations have led us to this stage. If you look at the wild varieties, from those wild varieties of plants, where you have arrived, it is so amazing. It is unbelievable that where we have reached today. And it's much more difficult to assess where in 5 or 10 years we will be reaching. Because of the human intervention, the evolution of the plants and animals has become much faster, much speedier. So it's difficult to predict that what will happen after 10 or 20 years. Coming 10 years, we'll see the evolution which thousands of years have not seen. So this kind of rapid change is going to happen, and therefore we need to be careful. Coming to another dimension of mobility and transport, because when we had shelter, when we had food, we wanted to have a faster communication. Improving our ability to transport goods from one place to another. And for that, the developments in the wheel is a kind of example that from initial invention to prototype formation and then further innovation, there are series of innovations, improvement, and eventually product which is in use in the vehicles, present day vehicles. This transformation we have seen, and this is basically incremental innovation over thousands of years which have taken place. Now, you see how the wheeled carriages have improved from single wheel to two-wheelers to three-wheelers and four-wheelers. One single discovery of creating a wheel has led to a variety of kind of carriages. And this is again the ingenuity that if one wheel can be useful, how we can connect two wheels, how we can connect three wheels, and how can we make more efficient carriages. Now, earlier, the animals were used for mobility. But after the discovery of wheels, the different kind of carriages were made, and the transport and mobility became much easier, and variety of kind of carriages happened. Now, a revolution happened once the discovery of James Watt of using steam came into the knowledge of the people. And these are some of the prototypes of the steam engine which was created, and eventually they developed into the steam engine. The steam engine, earlier the power of carriages was driven by animals. But now the power is coming from the coal. The coal which was buried earlier, and now we dig out the coal and start using it for generation of steam power. This further led to new kind of fuels, and you can see the process of coal formation. It starts from making peat, and based on the time period, pressure, and temperature, the lignite is formed and coal is formed. And in different kind of formations, you can find the gas and the oil formation. These reserves are formed under anaerobic kind of conditions. And then you have variety of kind of fuels, which can be coal, oil, natural gas, kerosene, and propane. And the fractionation, the process of fractionation was again a revolutionary process that at different temperatures, based on their volatility, you can and then condense it, and variety of kind of fractions of the crude oil, they can be separated. They start from the petroleum gas, gasoline, naphtha, paraffin, diesel, fuel oil, lubricating oil, and bitumen. All these fractions could be separated by this fractionation process. And many of these naphtha and paraffin, etc., they became source of plastics and pesticides, about which I'll be talking in a while. Now, all these fuels became a source for our faster mobility, starting from automobile, car, to lorries, to train, and also to the aircrafts. Now, what is the consequence of that mobility? We have dug out the petroleum, the crude, and this coal. All these things have been used to fulfill our wish to make our life convenient. And for that, we have excavated from the earth all these fuel, sources of fuel, and this has led to global warming. And the consequence of global warming can be seen in the health of the polar bear in 2009 and 2019. This is something which is visible, but there are many other things which are visible on the earth. We see, but we get used to it and we don't pay cognizance to that. But actually, global health on this planet is actually decreasing. And because of that, there was a call that we should shift from chemical fertilizer to biofertilizers and other alternatives. And there were 101 Nobel laureates. They gave a call for global fossil fuel non-proliferation treaty. So the fossil fuels utilization should not be there. And zero emission, carbon neutral, all these phrases, these anecdotes, they came into being, and sustainable development goals were planned. And timeline was declared that by this time, we will have minimized the use of fossil fuels. But thanks to Trump, all this has now been slowed down and is being reversed. Now, as I said that many of the intermediates in the fractionation of the crude oil generate precursors for making the plastics. And initially, the natural rubber was created by Goodyear, but afterwards, the new modifications came. The Alexander Parkus, he was the one who developed this bakelite, and the various polymers starting from these aromatics, they were created, and the polymer science, polymer chemistry, this became so popular. And variety of kind of plastics were developed, and these plastics, various applications were developed, and Nobel Prizes were given for the development and application of plastics. And first Nobel Prize was in 1963 for paving the way for making of the polythene. And then 2000 Nobel Prize was given for opening new possibilities in the plastic electronics. And you can see that a lot of applications of plastics have come up. Now, these starting from the natural rubber, the evolution over the years has taken place to polystyrene, Parkinson, PVC, vinyl or PVC, and then high density polyethylene, and then low density polystyrene, and you can see the polypropylene, styrofoam. And later on, all these developments and applications led to the plastic pollution. And then again, there is a call that this should be banned. Use of plastic, single-use plastic, at least we all know. But overall, we are all fed up with the plastics. And you can see the consequence of the plastic in this kind of situation. It has reached to our brains. the microplastics are reaching to our brains, and it is all the ocean life and water life, everything is affected by the plastics. So, one time celebrated discovery, consequence of highest ingenuity and the innovation, has now led to a kind of menace which is creating a problem for our survival. I'll give an example from another example for biological sciences. The discovery of antibiotics, the penicillin. This was done by Alexander Fleming, who did not realize that it will have such a great potential for human health. And it was much later, Fleming published his findings in the British Journal of Experimental Pathology in 1929, with only a passing reference to penicillin's application in therapeutic benefits. But later on, the Howard Florey, Ernst Chain, and their colleagues at School of Pathology at Oxford, they turned penicillin from a laboratory curiosity into a life-saving drug. Nobel Prize was given to Alexander Fleming. Later on in 2009, Ada Yonath, along with Venki Ramakrishnan, were given Nobel Prize for solving the structure of ribosomes. And the purpose of solving the structure of ribosome is that it will give the mechanism of the antibiotic action. And based on that, a lot of new generation antibiotics were created. And today, there is a call, rising antibiotic resistance, multi-drug resistance, extreme drug resistance. All this has taken place because of the overuse, misuse, or abuse of these antibiotics, that today we are at the brink of a greatest challenge of our survival, that when an extremely drug-resistant bacterium infects you, there is no cure, no alternative for the doctors. So we have to take with care that what is it that we are doing, and what are going to be the consequences. And that kind of responsible thinking has to be there behind every discovery. Now, coming to something which is of daily use, this little single device in our hand has replaced the old age cameras, video cassette recorders, the telephones, and many other applications. I mean, many other instruments. These factories have been closed just because this single device in our hands. Now, this single device in our hand, we can't live without it for 24 hours. If we lose our child, we are not so much bothered. But if we lose our cell phone, we are so much bothered. We are so dependent on that. Now, where are we heading for? We are transferring our intelligence to a machine. Now, we started with animal to human, and we were talking about application of our intelligence, ingenuity, and everything. And today, this is the height of our intelligence, that we can make machine more powerful than ourselves. And tomorrow, when we lose control of these machines, what is going to be the fate of humanity? Where are we heading for? That is the kind of challenge which stands before us. This artificial intelligence, the robots, whether they are useful for our Indian society, or we need to discover the technologies which empower every hand, rather than disempowering those who are already having the job. Because this artificial intelligence, believe it or not, is going to be a big challenge for employability of human being. Something which machine can do much better. The doctors are going to be unemployed. And many such professions, the teachers maybe will be out of job after some time. So we have to seriously think about it. Is this the consequence of civilization? The consequence of civilization is losing our intelligence, losing our ability to control machine, rather being controlled by machine. All these questions are very pressing questions. So I will end my talk with this little conclusion, that we have to shift sooner than later from fossil fuel or energy to biofuel or bioenergy, from a chemical fertilizer to biofertilizer, chemical pesticides to biopesticides, chemical plastics to bioplastics, from regular chemistry to green chemistry, monoculture to diversity, and exploitation to conservation. So we have to minimize our needs, ambitions, aspirations, and following the principle of reduce, reuse, and recycle for our sustainable future. With these words, I would like to thank you all for your kind attention. SPSTI, Punjab University, for inviting me here. Thank you. Yes, sir. आपने जो है बहुत बड़ा शिक्षा दिखा अभी this lecture
Now may I request Now may I request Professor Anil Grover, Dr. Gangaram Chaudhary, and Dr. Sahu present a gift as a token of gratitude to the speakers.
This was very Thank you. Yes.
Request him to please honor Professor Tuli. May I now request Professor Gangaram Chaudhary and Dr. Sahu to hand to Professor Grover. Thank you. Thank you, everyone. Now, at last, I request Seminar Coordinator Dr. Sahu to present vote of thanks.
Already we have passed morning. Yeah, okay. So I feel honored and privileged to propose a vote of thanks on the behalf of all the organized committee who made these events possible. First of all, I on the behalf of SPSTI organizing committee, including the NASI, Chandigarh chapter, and Chandigarh chapter INSA, INYAS, and CRIKC institutes for all their supports for these events. And my deep regards and thankful to our Professor Anil, Vice Chancellor, Professor Renui, for providing us the necessary administrative approval for hosting this event in our department this year. My sincere gratitude to Professor Rakesh Tuli, our guest of honor for today's event, who has shared his valuable time and graces the occasion. Thank you, sir. We are truly grateful for our esteemed speaker, Professor A.K. Tripathi, for sharing his valuable insights on the topic of human civilization through inquiry, ingenuity, and innovations. Your experience has provided us a deeper understanding and inspired us how the human development occurs through knowledge, creativity, and innovations. Thank you, sir. Yes. Actually, I was preparing the timetable and the title of the talk. I was very curious to know how the topic will be covered, what type of. But now I am really happy to see the entire topic. Really, sir. Thank you. So, our sincere gratitude to Professor Grover, Vice President of SPSTI, on this valuable presence and addressing the audience. My sincere gratitude to Professor Gangaram Chaudhary, our chairperson, Department of Chemistry, for his all kind of supports and help to conduct this event successfully. I'm very much thankful to all the eminent professors who are present here, including Professor Mehta, Professor Navneet Kaur, who introduced our speakers and guests of honors. My sincere thanks to Department of Science and Technology, Environment, Chandigarh University for their financial supports. And at last, my sincere thanks to Prof. Dharambi, who actually working behind the scene, the scene to arrange all this for the best from last 1 week, I can say. So thank you, ma'am. And at the last, the delegates and all the students who are present here, thank you for all your presence for making this event successful. Thank you. Yeah, and the online question boxing also, sir helped a lot. Thank you, sir.
Sir, few words from your side, sir. So I know it's midnight at your place. So, Professor Basim, so thank you so much for giving us this opportunity to organize this lecture. You were the first one who called us to host this event. So we would like to hear from your side, Madam.
Yeah, thank you. Can you listen me?
Yes.
Yeah, I'm really thankful to Professor Tripathi for accepting our invitation. As Dr. Sahu has just mentioned, how the lecture will be completed in all the three things, I3. I really feel so happy that you have presented the talk in such a manner that even a layman can easily understand. As a chemist of this department, I think I have been finally highly enriched because to shift from basically chemistry to particularly from urea to biofertilizer, it is too great. So I'm really thankful to all my other colleagues sitting over here, all the people, Professor Grover, Professor Pathak, so many people, and Dr. Kohli, and Dharamveer, and all these people. I thank you so much. I feel so highly thrilled to listen at this moment. Thank you so much once again.
To share with you that Dharamveer has arranged the next lecture on August 19th, and that's on aviation safety. So it will be delivered by former Director General of Aviation. And physics department in the physics department. And the Teachers' Day lecture will be delivered by Professor Kohli, but not on September 5 because that's an election day in the campus. On September 8, Monday, the 40 department. And the Engineers' Day lecture will be delivered by Director of FEC in UIED on September 15. So these are the next three lectures on behalf of all the organizations and all the institutions in our region, public lectures which will be webcast like today's lecture. So come and enjoy.
So all are requested to join by team outside.
Thank you very much.